Okay, well, this essentially is part two of our original first lecture here on structures, introduction to structures. Again, I pushed the stop button instead of pause, and I just wasn't able to pick up the video. So I could tell, though, actually, I was getting a little long on that last one, so it's probably good that I broke it up. So not much left to cover here before I want to wrap up this introduction. There will be one more lecture, and where we'll talk about using structures as function arguments, so that one won't be quite as long. So we left off with talking about the difference between char pointers and char arrays. And when you use a char array, you need to use the string copy function. And string copy will take this value and move it into this value. Okay, so you have source and then you have destination. With char pointers, you don't have to worry about that. Okay. The last thing I want to talk about is how do we declare a pointer of a structure type. Okay, so we've been working with our struct employee. In this case, we're going to go back to the employee, so not the employee two. Again, we'll just look at those real quick to refresh your memory. Employee, okay, first name and last name are char pointers. Employee two, first name and last name are char arrays. That's the only difference. So at this point, that's negligible. We don't really care. So we declare it like we do any other pointer. Right? We define the type, we define the variable name, and then we add the asterisk. The asterisk just needs to come somewhere between the type and the name. Okay, so we can put it next to the variable name itself. We can add a space in between. We could put it next to that. It does not matter as long as it's in here somewhere. Typically, people become consistent, and that's just what they do. If you're really interested in getting into why move it to one side or the other, you can Google it and you'll see plenty of conversation about it. Quite honestly, quite frankly, I don't really care. As long as it works, that's all I really care about. So what do we do? Well, we already have a employee. Okay, if we go back in the code a little bit, and how about we just grab this? No, I'll leave it. I'm going to take this initialization list out because that's how the code originally started. That's what you'll see here when you look at this uploaded code. So we have a variable type struct employee, and we've gone through and we've initialized or assigned a value to each member. Okay, so first name, last name, age, gender, and salary. Now down in here, if I want to declare a pointer, I just have to use the address operator on the name of that variable, right? And that'll assign the memory address that was assigned to that structure typed variable to our pointer. And now with that, if I want to access a member through the pointer, we use the arrow operator. Okay, so it's a pointer. It's still pointing to when this guy was created right here. Memory was allocated for it, and we're storing those values in those memory locations. All right, just think of it simple right now. Each member has its own memory address. Okay. When we assign a pointer, now the pointer is just pointing to those same memory addresses, right? So when we change those members through this pointer, we change them globally. We change them in that one memory address. So now we can use that arrow operator. I could say, let's print off the first name. So we'll say first name, and we'll do a tab, and then a %s with a new line. And we'll print off first name. So ePointer, so the name of our pointer, a dash and a greater than sign, and then the name of the member. Okay, so when you're accessing a member as through a pointer, you use the arrow operator. Regardless of the member type, you use the arrow operator. All right, so now if we compile this and run it, let's see if it works. Okay, good. There you see. We got first name, our tab, the first value of first name member, and then a new line. Okay, so that works. If I wanted to change it, okay, let's say that I want to change the value of the first name member, and I want to do it through the pointer instead. I could say ePointer first name equals, and I'll do what I'm doing later on in the code, updated. Okay, so that's just to signify that it's changed. It was initialized to my actual name, which is Josh. Okay, you can see here on line 42, that's where I'm doing that. But we'll change it using that arrow operator. So we'll go back into the code here, compile that program again and run it. And there you can see it's changed to updated. All right, so bottom line, arrow operator we use with pointers. The dot operator we use with non-pointers, or just variables of that data type. So this is how we declare a pointer that's going to point to a type of struct employee. We have to assign the value to that pointer, and we could even condense this a little further. We could just initialize it right off the bat using our address operator and the variable name of a variable that is a type of that struct employee. All right, so that's it. That's our introduction. Again, we've covered quite a bit, and I try to cover not only the basics of structures, but a couple of the gotchas, at least the stuff that can cause frustration early on. So just keep in mind, okay, we declare those structures at the top of our code before our main. We need to use the struct keyword and then the identifier tag. So what do we want to call this structure? What data will this structure represent? Okay, curly brackets and with a semicolon, and then our members. And those members can be primitives, those members can be aggregates, those members can be other struct types. If we look at this one here, actually, we'll do this real quick. And let's say that I want to declare struct. Well, if I say struct employee, okay, so that's going to be a member of the same type as the structure that we've defined. And I'm going to call it, let's call it boss. Okay. Now, we can't do this, right? We have to declare these if it's going to be a member to another structure itself or another structure. Even if I did, let's say that all of us employees have a card, right? Either way, it's wrong. Okay, you cannot, they have to be pointers. You cannot define them like this. It doesn't matter if it's pointing to itself or a struct of itself or a different structure. So I said that will generate some kind of an error or warning. Let's find out. It's an error. All right, good. So it won't actually let you compile it. It hit this error and it stopped. Okay, so we need to fix that. If we want to fix that, then we need to make it a pointer. That's all we have to do. Okay, now we go back and compile that. Errors are gone. Okay, and so we're all set. All right, so declare those members. We talked about that. Fix that up a little bit, and then just going through this code. Okay, we were able to declare one. We can use initialization list. If it's not a pointer, you can use the dot operator. Okay, so this is an example of doing that. If it is a pointer, then you use the arrow operator. So in the case, we would use the arrow operator here as well as here. And then for the next lecture, we'll use the same code and we'll take a look at these two functions. Okay. All right. Let me know if you have any questions. Thanks.